Hi everybody, welcome to part whatever. So what we're going to do today is do the alignment on the tuner. Some of you really like this. Some of you, parts of the world that don't really have a lot of FM or AM broadcast, probably doesn't matter to you, but over here it does. So I'm going to try to do this according to the instructions. I could connect up the SG-80 and blow through this very quickly, but I'm not going to do that. I'm going to take my time and I'm going to try to follow the instructions to kind of see what it was like, to show what it was like to do it the way that Pioneer suggested in the service manual. And in order to do that, you have to have some certain equipment. If you don't have the right equipment, it's not going to be possible to do this. So what you see here is they want you to connect a distortion meter and an AC voltmeter to the tape outputs. And I've done that. You see this copper colored coax here. It's actually going over here. Yeah, the camera's wonky, but just to show you real quickly, it's going into here, into the input, and we're going to use the built-in meter in this, the signal meter. I'm set to RMS volts and it's on auto mode, and I have the THD multimeter, you can see connected right here, going into there. So they're just kind of teed together, just like the instructions say. All right, when it comes to the time of the procedure where we're going to use that, I'll move the camera and center it properly and everything. Okay. We're also going to get just an FM signal generator. We're going to come out of the output of that, and we're going to go into the input of the 300 ohm antenna jack through a Ballon. And I have that back there, and you can see this white wire right here. It comes out of the signal generator. We're going to use the HP 8657 on this one, and that's going to allow us to give us the setup that we need. We're going to go into the modulation input, the external modulation input of the 8657 from our Sound Technology ST1000, the 1000A. So I'm just going to use this as a multiplex signal generator, just like this. Now, the 1000A does have its own FM signal generator, but once again, I want to do this the way that I'm going to show you the setup, how it's wired. Okay, you can just come right out of the RF output of this as well and not use that, but you'll see why I'm going to do this here in a minute. We are also going to come out of the pilot out. Now this is the problem that we have with the Sencor SG-80. It does not have a direct pilot signal output, so we can't actually connect this to our scope to do the Lissajous pattern like we want to do. So that's why I'm doing this setup this way. I want you to be able to see this pattern. The other input, so that's going to go into the horizontal input of the scope, and the scope is going to be in XY mode. And then the vertical input of the scope is going to be fed by a 10-to-1 probe off of test point 13. And that's your setup. Now, we're not going to use this part for the first part of the procedure, as you'll see, but as we move through, we'll activate this. Right now, we're going to go to part 1, and this is your FM tracking. So this is just getting the FM to track just in mono mode. So you're setting your dial accuracy, all that stuff. That's what this first 13 steps is going to be all about. All right, so I'm not going to keep putting this on the camera. I'm just going to show it to you. If you want to read it or look at it real quickly, you can stop the camera, and then I'll give you the other half here. You can look. All right, so you start out at 90 megahertz. So I have it set up to 90 megahertz. They want maximum deviation and a 400 hertz internal modulation. So we're not using this right now. We're using the internal modulation. So we have a modulated signal, 90 megahertz, going into the antenna. And let me move the camera down. Okay, we're going to do one little side note here before we move on. You're going to find out that I am using, for the all the alignments except one, I'm going to use microvolts. All right, so if I say 60, I'm going to go 60 microvolts, and you see the little microvolt lights up. If you look in the instructions of a lot of the Japanese equipment, like Pioneer, they refer to just dB or decibel with no reference, and it can be very confusing. But some of the Japanese signal generators just use the word dB like this, and what they're really referring to is dB femtowatt. Okay, a femtowatt. And the problem is, whenever you're dealing with decibels of power, okay, which is, you know, watts, a femtowatt is very small, but it also has to be tied to a certain load. So if you look at this meter, or this signal generator is always referencing to a 50 ohm load, or 50 ohm termination connected to the output of this. And of course, commercial FM tuners like this one will either have a 75 ohm termination or a 300 ohm termination, and that can adversely affect this number here, because you're actually feeding the signal into a different load than what this is showing. So whenever you're dealing with watts instead of electromotive force, which is volts, this number is going to be off. Now, what you're going to find out is I just use microvolts, like I said. So whenever they say 100 dB, I just set it to 100 microvolts. That is much lower than what a 100 dB femtowatt is. And it depends on the load. I mean, if I go to 100 dB or 100 microvolts, that's 100 microvolts, right? Or 100 millionths of a volt. But if I go to 100 dB with reference to a femtowatt, it just says 100 dBF, but this is assuming that this is connected to a 50 ohm load. All right, so that's why when you deal with anything in the power range versus electro EMF or voltage range, it can get confusing very quickly. If you remember, they have us connect this into the 300 ohm termination through this dummy load coming out of the signal generator. And a lot of these Japanese signal generators that were purpose built for this type of equipment, they actually will have a 75 ohm termination instead of a 50. So you can see how rapidly that gets confusing. But as I say in this video, you have to remember what I'm saying. I use microvolts, and it's a lower signal level, and I just tweak it a little bit if I need to, if the signal is too weak or too strong. Because really, what they're trying to get you to do is, when they say 100 dB, that's a strong signal, and when they say, you know, 6 dB down here further, they're talking about a weaker signal, and when they say 60 dB, they want a medium strength signal. That's really what they're talking about. Now, the only time that this becomes a huge deal is when you're trying to set a meter range. So if you have a meter that actually reads dB or reads some sort of signal strength with some sort of reference, then that signal has to be accurate. So you have to calculate this dBF into a 300 ohm load, and basically you have to convert it from a 50 ohm to 300 and then figure out what setting here gives you that setting there. You see how complicated that can get? So, long story short, I'll put a little chart up that shows you a little bit of what I'm talking about. But just know that I am using microvolts, and I'm using three main signals. I'm using 100 microvolts, 60 microvolts, and like 5 or 6 microvolts. And that works just fine. The only time that I'm going to get a little, try to be a little more accurate is when I'm setting the last setting, which is the signal strength meter, to read on that scale. And we're going to, for the first part of this, we're going to use the signal strength meter to peak the signal out on the different frequencies. So right now we're set at 90 megahertz, and I'm exactly on it. The camera's facing at an angle, but looking straight at it, I'm directly over top of it. All right, and there's your signal strength meter. They want you to put a 100 dB signal. That is the Japanese dB scale. That, don't ask. This isn't super critical, so if your cable matching isn't perfect, like I'm using a 75 ohm cable into a 75 ohm input with a 50 ohm terminated signal generator, there's going to be a very slight difference. So if you were setting a signal meter for accuracy, you would not do this, but for what we're doing, this is fine. So I'm just doing a 100 microvolt signal, and we're going to adjust right over here. We're going to adjust this little can right here. You can just kind of see it. And we're going to set that for just maximum peak. So you can see I'll put the alignment tool in there. I'm going to go down to the meter, and it's probably already peaked out. So I'm going to adjust it. You can see it's dropping again. So you can see right when I'm on that peak, the tuning meter is centered. So it tells me that the detector circuit and everything is probably going to be spot on. We're not going to really adjust much of anything. And it's not, it won't surprise me if this thing's absolutely dead on or very close to it. Now, in the event that the meter was peaked out, but the centering meter was off center. In other words, if this was not reading center of frequency when this was at its peak, then we would have to go into our detector coil, which is this one right here. And there's two sets of slugs in there. There's an upper coil and a lower coil, and an upper core and a lower core. And in order to get to that, you need a special tool. And what you need is one like this one that kind of has a shanked down shaft on it. And what you're going to do is you're going to put this in here. And actually I have a better one in here someplace that I made specifically for this job. There it is. I will get it out, if you all don't mind my time here. And you can see the difference between the two. If you look at this one and this one, you see how I cut this one down a little bit? And the reason that, boy, how fast this new camera focuses. So you see how it's shorter? And the reason being is that when we go down here, the first core is right up here. I'm going to go all the way down through that core, so you can see this is just spinning freely, it's loose. And I'm going to go down into the bottom core. It's down in the bottom, just like that. Then I'm going to adjust it, and that's the one they want you to adjust. If you leave that to its full length, what happens is it'll actually get stuck between the two cores and move them. So that's just a little modify. You can buy these things very cheaply online. And what you would do is, I don't have to in this one, but I would then adjust for this meter to be dead center on the center tuning mark in the meter itself, the little mark in there. As you can see, it's right on, so we don't have to touch it. Okay, for this next one, we're going to drop down to about 8 or 10 microvolts. So you want a really, basically a really weak signal, and you can see it down there, how far down the meter is. And conversely, you can see up here, and you can hear it. If I move my microphone, you can hear. Okay, there's the signal. And all we're going to do is we're going to peak the signal out once again, and we're going to use the signal meter, but I'm also going to monitor this as I'm doing that. So go down to the signal meter. We're going to follow to the letter what they say. And they want us to do T1, T2, and T3, which is going to be these 3 coils over here. So you have T1, T2, and T3. So this is 1, this is 2, and this is 3. If I can get the meter in there. I'll just show it to you. There they are. 1, 2, and 3. I'm looking through the meter, or through the camera. And we're going to adjust those for peak. So let's go into number 1. And we're going to adjust that. And you can see it's pretty much, that was a wee little bit off, not much. Number 2, that one was just absolutely dead on. And number 3, that one was off. You can see how it was. So we got a little bit out of that. So number 1 and number 3 were out ever so slightly. Okay, that's the bottom end of the band. So now we're going to go up to 106 megahertz. So you can see I'm just going to move this up, and you can hear as soon as I go off the signal, you can hear the static coming through the monitor speaker on the PA81. I really like that PA81. Alright, so we want to go straight on to 106, and then we're going to change the signal generator up here to 106. So frequency 106 megahertz. And you can hear once again. And we're going to go down here. We're going to do the same thing, except instead of adjusting the coils for the high band, we're going to adjust the trimmer capacitors. So we did T1, T2, T3. Now we're going to do TC4, which is going to be this little capacitor here in front. Right there, this little capacitor here in front of the coil. And then we're also going to do TC1, TC2, and TC3. And that's going to be these 3 along here. And that's going to be TC1, TC2, and TC3. And I'm telling you by the meter that TC4 does not need adjusted at all. And the way we can tell that, because what's going to happen is if I tune up and down on the dial, see that? You got a wee little bit, just a wee little bit, not really. I'm splitting hairs there. So I can use TC4. It's a wee little bit off, so I'll demonstrate to you how to do it. Let's put it right center, right on the center there. And then I'm going to adjust TC4, which is your oscillator coil. And this thing is super touchy. I'm going to move it and it's going to go right off. See it? And then I'm going to creep back up on it until it peaks out. And this takes, you really got to be careful because that control is really stiff. Right about there. That's it. That's about all I can get. All right, now we're going to go back to the coils, and we're going to, or I'm sorry, the capacitors that are on top of the tuning gang, and I'm going to do TC1, 2, and 3. So here's number 1. You could see it was peaked. Not. I got a little more out of it. TC2. I got a little more out of that one too. And TC3. And that one was pretty bad there. We were peaked out on that one. Okay, so that one was good. And there you go. So your dial accuracy is done. That's all there is for that. Now the next thing they want you to do is go back to that T6, which is that big coil right here, and they want you to go to the bottom core again and touch it back up so that this center meter is center again. Again, it's right on, so we're not going to touch it. Now we're going to go to 98 megahertz. So we're going to move the tuner over to here. We're going to put it right on 98 megahertz. I'll turn that static down because it will drive me insane. And now what we're going to do is we're going to adjust the top of that aluminum can, again, that T6. The top coil we want to adjust for minimum distortion. So let me get the alignment tool in there. And all we're going to do is adjust for minimal distortion. Okay. That was the wrong way. And this is very touchy also. I have a feeling it's, no, it's going down. There, I just went through it. Well, that was quite a bit. That's about all I can get. Just breathe on this thing and it moves ever so slightly. Kind of really hard to get that last little bit right there. That's it. I'm done. I'm not going to move it anymore. Okay, we're still at 98 megahertz, and we want to, now we're going to adjust, let's see here, we're going to adjust the power or the output of the signal generator up to 100 microvolts. And then they want us to adjust VR2, which is the meter adjustment, and they want us to set that for maximum deflection on the meter. So I kind of like it to be in the white area at that. So you can see right here, that is going to be our pot that we're going to adjust. And I'm sure it's going to be touchy too, because these single turn pots get really crusty with age. But let's adjust it. It's pretty much on right now. I mean, it's a wee little bit off, but and you can see I just barely touched it. So I usually put it for, you know, pretty much in the middle of the scale here. They tell you maximum deflection. I just put it kind of like that. Okay, FM alignment is done. So now we're going to do the multiplex stereo adjustment. And in order to do that, we're going to have to use the oscilloscope. And we're going to, actually, there you go. I set it this way, and that's actually what they're showing for the meter deflection, figure 18. So there you go. It's not right on the 5. And that's kind of what I meant. All right, now let's go to the multiplex, and it's the most interesting thing because that's what we had to do all this for, all this setup and everything. So now what I'm going to do is I'm going to go over here and straighten my camera so it doesn't look all wonky. I'm going to turn off that, okay, the internal modulation, and I'm going to go external FM, And do you hear that? It's a 1 kilohertz tone, and that is, now we are using the 1000A, and I have it set right now to left plus right, and I'm coming out of the composite output, which is just the multiplex signal only. That's another word for multiplex or MPX signal. And it's going into the external modulation, and it's modulating this 98 megahertz frequency. So with it set at 98 megahertz, modulating our stereo signal, the first thing you should notice is we should have a stereo indication, and we do. We should be at center of tuning, and we are. And then you want to go over to the distortion meter, and we should have a relatively low distortion. Again, the manual doesn't tell you this, but look how low that is. That's absolutely phenomenal for modulated FM like this. Okay, what we're going to do now is adjust the pilot detect, which is this one right here. And the way they have you do it is with a XY pattern, and that's why that scope's set up that way. And you can see this is how it looks, and this is how it always looks on my scope here. If you look at this, they show you a really neat looking pattern. Very rarely can I get my scope to do that. It just doesn't react that fast. and I can't get it to set like that. But here's what it normally looks like on every multiplex circuit that I do with this. This is how it looks. And I'll show you the adjustment to make it look like that, because quite often when you get it, it'll be a little bit off. Where these intersect, notice how they're down towards the bottom of the waveform, and that represents this crossover right here. And it's not going to be perfectly centered. Don't worry about left to right. What we want to do is, you can see if you go too far, it starts to oscillate. See that? And you lose your pilot detect, and you also lose the stereo indicator light. When you get it in, so I'm adjusting that pot, that VR3 again. What is that? VR3, yeah. And there it pops right in. You want it to be kind of down towards the bottom, just a little bit up off the bottom. See how I have it right there? There's all the way to the bottom. There's just a little bit up right there. And if everything looks good, your distortion meter should still be reading that real low reading it was when it was on mono. If I go the other direction, you'll see this will start moving up, and you'll see the sides will start shrinking down, and eventually it'll oscillate in that direction. So you want this amplitude to be as high as possible, and you want this cross section to be almost down to the bottom. See that? Just before it starts to oscillate. Right about like that. And that's going to make sure that this thing kicks in with a very low signal. If that's not set right, what's going to happen is weak signals are not going to kick into stereo mode as easily. So that's why they have you do this. Again, there's different methods. I don't use this method normally. I use the PA or the SG-80. And you've seen me do all this. I did a whole video where I used multiple types of test equipment on a Marantz tuner with this similar circuit. So go back and watch that. But once you get that dialed in, this is what it should look like. You should have a nice right and left channel. You should have a nice low harmonic distortion. Your stereo indicator should be on. Center of signal should be over center of signal. And that's all good. Now if I start going down in amplitude, There's 31 microvolts, and you can see it's still locked in. It looks perfect. If I go down to 10 microvolts, you can hear I'm just starting to get a little bit of static, and you can see even with a 10 microvolt signal, I'm still getting only 0.24% THD. So this thing's dialed in very well. Let's see how far down we can go and keep stereo. There's 3 microvolts, and you can see it's starting to twitch. And we lost our pilot detect. So if I go up to, let's say, 5 microvolts, it locked in. It's still twitchy a little bit, but it is locked in. And even with a 5 microvolt signal, see that? I'm only getting just under 0.4% THD. And I get a pretty respectable looking right and left channel. Not too shabby. Now, the next thing we want to do is our separation adjustment. Okay, next we want to adjust VR4, which is this one right here, and that's your stereo separation adjustment. In order to do that, we're going to have to kick this over to right and left. So I'm going to start out with left, and if I look up here already, you can see my left channel is still perfect. My right channel is almost totally flat, and if I adjust that R4, I'll show you what it does. See how you start getting some bleed over into the other channel? You want this channel to be totally canceled out. So right about there. It was a wee little bit off, but probably not recognizable. So there you go. And then we're going to switch over to the right channel, and you can see it's perfect. You just want to make sure they're both flat like that. And we'll go back to right and left. All is good. Now, last but not least, we want to adjust the pilot cancel. What is that? Okay. Well, for the multiplex signal, you have your 19 kilohertz pilot tone. And I'm not going to get in that. I have multiple videos, once again, where I did that. And you don't want that 19 kilohertz. Of course, 19 kilohertz wouldn't bother me. I wouldn't be able to hear it. But you don't want that pilot tone bleeding through your audio. Remember, FM stereo cuts off around 15 kilohertz, maybe 17 kilohertz. It doesn't cover the entire audible frequency band. So that's just the way FM is designed. So that 19 kilohertz is nothing but a pilot tone to tell the stereo that there is a stereo signal present, hidden inside the modulation. And you don't want to hear that in the speakers. You want that to be filtered out. So there's a 19 kilohertz trap, as they call it, and that's going to, you're just going to adjust that to cancel that 19 kilohertz out. Now VR5 is this one down here, and what I'm going to do is I'm going to leave the 19 kilohertz pilot tone on, and if I hit this test, you can see it's set to 100%. So that pilot tone is all the way up there where it's supposed to be, and I just took the oscillator level and turned it all the way off. If you notice, that killed the sound. See, here's your sound. That kills it, okay? So now there's nothing left but the 19 kilohertz pilot. And you need a really sensitive voltmeter for this, and that's what this PA81 is all designed for. And you can see that, just that tiny little signal there. And what we're going to do is we're going to adjust that VR5 for minimum signal, and I'm pretty sure it's already there, but we're going to check anyway. So you can see, nope, it's not. And there, I went through it. So yes, the pilot trap was not properly set. There it is. Okay, this is going to be a very good performing tuner now because it's perfectly set. Okay, so as you can see, it's working very well.
Your teacher, Alex Campbell, though the Tennessee Bureau of Investigation.
And it's going to be coming our way on March 29th. And make 0 payments till spring. Or lease a new Kia for $139 a month. Like a new 24 Kia Forte LXS with $34.90.
Perfect. So it is working just fine. All right, let's go on and do the AM. They want it 600 megahertz or 600 kilohertz. We're going to start at 100 dB, which is 100 dBF, which is again a very strong signal. And then they want 30% modulation at 400 hertz. That's what they're calling for in the book. Looking at the scope, you can see the signal is jumping around even with that really strong signal going in there. And honestly, looking at the tuning dial, I'm dead on 600 kilohertz, so the dial accuracy is good, but doesn't seem like there's a whole lot of you'd think there'd be a lot more signal strength when we're talking about that kind of signal going in there, but maybe something needs to be adjusted. Okay, starting to adjust T7. Well, that sure did. Looks like I'm going to have to go up one. Definitely, that is a touchy adjustment. There we go. That's about as far as it'll go. So we did get a little bit out of it, but I still have an awful lot of static. Now we're going to switch over to 1400 kilohertz or 1.4 megahertz, like that. Everything else the same. And we're going to adjust TC6. So first we'll go up to, what did I say, 1400. And you can see we're off a little bit there. So we're going to put this on here, get it right on signal, and then we're going to adjust TC6, which happens to be this one right here. And you can see we don't even have a signal right now. So I'm going to go up here. I'm just going to turn TC6 until that comes in. There you go, just like that. And then I'm just going to kind of creep up on it. There we go. Oh, popped right out of it. You can see that's a pretty wonky looking signal also. But that's it. I'm on it about as best as I can get. And I could be picking up interference from the bench. I mean, anything's possible. Well, it's a good thing we went through this because as it appears, this radio is deaf. They want you to go down to 30 dBF, and they want you to adjust the bar antenna at that point. But if I go down that far, I lose my signal. So let me just get everything in camera here, and let me show you what I'm talking about. If I go up in amplitude, this is the dB, 40, 50, 60, 70. It's now just starting to come in. 80, 90, 100. This radio is deaf. And what that tells me is that there's something either grossly out of alignment or we have a bad component in the AM tuner. Okay, I'm going to cut to the chase here. I have a capacitor with a just connected to my signal generator. I have 20 millivolts of signal at 455 kilohertz, which is the IF signal. And if you look at the diagram, internal diagram of the HA1157 IC, you have your oscillator mixer right here. And basically this is the whole radio on a chip, and the only external components are a few capacitors and your coils, your IF coils. Now if an IF coil is bad, then we won't be able to pass the signal through here. So the first thing I'm going to do is we're going to start at pin 5. I'm going to feed a signal into pin 5, then pin 8, then pin 9, then pin 13, because that's the order that it goes through the amplifier. So you have pin 5, and that's your oscillator coil. The oscillator is then going to get mixed in here with the IF and so forth, and you're going to get, you should have your 455 modulated signal go into here. So let's go to pin 5, and that is going to be over here, 1, 2, 3, 4, 5 on this side. Let's see what it looks like on the scope. Okay, 1, 2, 3, 5. And I get a signal. It passes it. Now, there's not much of a signal, but it's there. And that's a 20 millivolt signal. That's pretty hot. So the next one would be to go into pin 8, because pin 8 is on the other side of the IF transformer. So 6, 7, there's pin 8. And it's really amplifying it there. You see that? And that shouldn't be like that. And then if I go into pin 9, I get nothing. Pin 9 is right here, is the input to this transformer. And again, that's going to be, you're not going to have any of this amplified signal here, so I got to go way up in amplitude. So let me crank that up. Let me go into pin 9. And you can see I get a great big clipping signal. Let me turn it down a little bit. So yeah, that's working. And then pin 13, again, I'm off the charts. There's pin 13. So yeah, look how much 13 and 9 I have nothing. Oh boy. So here's 2, 3, 5, 8, 9, and 13. And it seems like I get more amplification on 13 than I do on 9 or 8. There's 8. That's not right. 8. 9 is nothing. So yeah, there's a lot of problems in here. So I am losing the signal between pin 9 and 13, which is right here, IF transformer number 2. Well, I do believe I found the problem, and you can tell me if you could see it. See the little capacitor in the middle there? See how all corroded up and like looks like it's arced up or something? I don't know. I don't know if you can see that or not. Now, according to the schematic, it's a series capacitor, so there's nothing in there with it. So I should be able to get my capacitor tester, and we should be able to read it. Okay, let's see if I can get on this thing. Without shorting anything. Well, let's bend these out of the way a little more. Okay. Let me see. Gotta be a little bit patient with this. 183 picofarads. I don't know if that's supposed to be 183 picofarads. That sounds reasonable. I hope I can get in here and you can see what I'm doing. So if I go from this end to this wire, that's pretty much a short. So that's the end that goes directly out to the pin. This end should go through the coil into the pin. And it is reading a 4 ohm coil. Now, what it's not reading, so basically from here to here, I should have some sort of inductance. Well, as it turns out, I did not have an HA1197, but I do have an NTE1214, which is the same chip. Who'd ever thunk it? Okay, the new chip is installed. And remember before when we had pin 8, you got a signal, and then you went to pin 9, it kind of died out. Watch now. Here's pin 8. Here's pin 9. And here's pin 13. Look at that. It's all there. So that did it. It was a bad chip. Okay, looking at the signal, it is better now. I still don't have a lot of sensitivity, but I chalk that up to being down here on this bench because there's a lot of noise. And one of the shortcomings of this receiver is that when you compare it to the 1250 versus the 1280, which is what this is, the older ones have shielded circuit boards and everything. They took it a lot more seriously than this one, and I just think that this is just as good as you're going to get it. That chip was bad though, as you could see, between pin 8 and pin 9, or in 9 and 13, it's now acting more like I would expect it to, and you can see the signal's not too bad. So I'm going to call this one done.